Hello everyone, welcome to Stack Tech. In today's video, we are going to discuss the part 2 of the Spark streaming video. So, if you have not watched the first part, please, I would suggest you watch that. In that, we have discussed regarding the streams and how it works and all the other stuff. So please watch that video first before diving into this video. And let's start today's video. So today we are going to discuss like what are all the transformation which we can do over the streaming data. So here basically there are two kinds of transformation, stateless and stateful. So stateless transformation is the one wherein you get a chunk of data, you process the data, but you don't you do it in micro batch processing, right? And here you don't need to remember or keep the state. Like you do a flat map, you do a map, or you do a reduce by function, but in this you don't need to be aware of the previous state of the operation. Like if there is a stream of data like this, and what a stateful operation does is that it needs to see all the other transaction, all the previous state transaction before going to the next state. But in case of stateless transformation, you don't need to do that. You only need to see the current state, not the previous state. Like what it does in the stateful transaction, suppose we are having a telecom based data and marketing team wants to sell some offer to a person which are using more messaging service. So what it needs to do in that case, it needs to get the data from the last 1 hour or last window period. So that is a stateful transactions. So these are worked upon the periods and the updated state by key, update state by key methods. So those kind of transformation are stateful in Spark streaming, which operates on sliding window operations. So there are two types, like window length, like for an hour we want to see like for 1 hour how many tweets came in, and we want to count it based on that window length. Then we can define it in the window length, and we define the window length and the sliding interval, like how often or what should be the interval at which the window should slide or move ahead. So here we can customize based on your use case. So for this, in this example we have set it for every minute, and it should slide after 5 seconds. So every 5 seconds we should get the count. So based on these based on your use case, you need to define this. So this is what stateful and stateless operations and window operations in Spark streaming are. Then we can also have cache and persist, as we have in our other transformations or other batch processing systems. So by default, cache it does it in a memory only, and it's by default. Persist, where we can define the memory level, like memory only. By default it is memory only persist. You cannot change this after you start the stream. So you need to bear in mind this, like you cannot change the storage level after you start the streaming context. Okay, so you should plan your application according to the requirements before you start streaming. Checkpointing. So the next point here is like for recovering from a failure, you get some messages, you process those messages, but now suddenly your application goes down, or cluster is away, or it goes down, cluster is down for now. So how can you recover from the system, and when your cluster is up, how you can recover? So you need to maintain some checkpointing mechanism, and these are the steps how we can do that. So first you need to run the program. Second, you need to set up the streaming context which we discussed in the previous video, and then you need to start. Then the application restarts from the failure. Streaming context is created from the checkpointing data in the checkpointing directory. Here the checkpointing directory is the checkpointing for your application. So you need to decide like what would be your system. Like there can be a number of things like how you can design this. Okay, so this is what checkpointing is. Like you define it in the directory or some storage location. Fault tolerance, so we can have at most once, almost once, at least once, exactly once. So Spark streaming provides the strongest, that is exactly once. So how it provides, we'll see. So in case of worker node failure, so Spark has the ability to recover from the failed receiver state, but it depends on the what the source is, or is it a reliable source, like is it a S3 or HDFS, then we get the exactly one semantic. But if it is an unreliable receiver, like reliable, there are two kinds of receiver, reliable and unreliable. Reliable is wherein you get the notification once you replicate the data to the nodes, or you do some processing to the nodes. Unreliable receiver where you don't get the message, so that is a unreliable source, and in that case you get at least once, where the data has been replicated but you don't get the notification, so it may be lost and it would get at least once. So in case of driver failure, this is a particular concern. So if the driver fails, this kind of situation, there will be a loss of data, particularly in case of stateful transformation. This won't affect stateless transformation, like we don't have to keep that into memory, like we saw in the stateful, like last 1 hour data we need to keep, and your driver node fails, so in that the data will be lost. So that is what will happen, and Spark streaming provides exactly one semantic wherein the data won't be not be duplicated, and whatever we discussed in our last video regarding storm, so that those cases like idempotency and multiple tweets don't get repeatedly counted, or those kind of scenarios don't happen in Spark streaming, which could happen in other like storm. Worker failure impact, like under the hood there is a RDD which is working on it. So as we know, it would be computed in a lineage. So as long as that input data is available, so there won't be any data loss in case of these streams, as under the hood there will be a lineage. So the data loss in D stream would be less as compared to other streaming platforms. Worker failure impact on output scenarios. So in the event of a worker node fails, the output operation by default provides semantic of at least once. So this may be a case like if you want to write it into files, so that is automatically taken care of multiple updates by ensuring that only one copy exists, so not duplicated copies exist for your final operation. So this may be problematic in case in some scenarios where you want to achieve exactly one scenario, but this is now for in the structured streaming. These all things you no need to require to be done. So in this stream, if you want to achieve at least one scenario, at least one semantics, this scenario you want to achieve, so you should do some re-engineering or some changes in your operation, or how your how your application would work. So if you want to achieve this, so under the hood you need to also analyze this failure impact on the output operations. So that's it for today, guys. So thank you for your time, and we'll see you in the next video of Spark Streaming. Bye bye.